Hello, students. This is Anurag Tiwari, lecturer physics from Springdale College, Pilibhit. Since there is a very serious events happening around us, that is a corona COVID-19 virus, and all the colleges, schools are closed. So I think that it is better to being sit alone in the house. We should do some work which is related to our educational studies. So here there's a very short briefing about the how the nanotechnology is important for our future, and how the carbon nanotube, which is very growing concerning subjects in present era, why it is important. So there is a brief video about that. In this session we will discuss about the objectives, why nanomaterials are important, what is carbon nanotube, types of carbon nanotube, vector representation of carbon nanotubes, comparative studies, method of synthesis, type of chemical vapor deposition, thermal chemical vapor deposition, optimization of parameters, instrumentations, advancement, disadvantage, problems regarding CNTs, and there are some references also. So the objective of this study is to just learn the synthesis of carbon nanotube, how the mechanically carbon nanotube can be growth, and optimization of different parameters to identify the best one. On going forward, it's really the first we should understand that why nanomaterials is all concerning about. The best thing is that it's optical properties free from imperfection, because when we decrease the size, when we go lower in the size dimension, basically we obtain the perfect crystal level structure. That's why the highest mechanical properties such as Young's modulus and elastical strength, chemical properties being evolved, and electrical properties become so much good. Now moving forward, that carbon nanotube is basically formed by the carbon graphene sheet. Okay, there's a graphite structure of two-dimensional graphene sheet. When we rolled up that sheet, it turns out in the form of cylindrical tubes called as carbon nanotube. There are basically two type of carbon nanotube. That one is single walled and other is multi walled. Single walled carbon nanotube are further classified in zigzag single walled nanotube, armchair single walled nanotube, and chiral single walled nanotube. If you go through this structure, then there is a vector taking the reference point 0 comma 0 to n comma 0. If we rolled our graphene sheet along this vector, then we can find out the rolled graphene sheet is belongs to zigzag criteria. And if we rolled our graphene sheet along this particular diagonal, then we got the armchair. Okay, now if you see, the blue lines is here is just representing the structure of some type of chair. That's why the rolled graphene sheet is called armchair single wall nanotube. Now, the best part is between these two lines, we got our chiral nanotube. You see, the resultant of these two vectors, n comma 0 and n comma n, we get our chiral nanotube. The angle between these upper two vectors is if theta, then the interatomic spacing d for the chiral chair can be determined by a by pi root m square plus n square plus m times n. Now, now we discuss about the synthesis of carbon nanotube. You see, synthesis of carbon nanotube can be done by basically two processes of obtaining the physical and chemical. Of course, the physical process are being further classified in three methods: arc discharge, laser ablation, and plasma torch. On the other hand, chemical process can be further classified in catalytic growth method, free catalytic growth method, and chemical vapor deposition method. Here we discussed about the chemical vapor deposition because on the study was found that the best method for obtaining the good quality and the good yield of carbon in a tube is can be possible by chemical vapor deposition. There are some different types of chemical vapor depositions abbreviation are representing over. I'll tell you that it is thermal chemical vapor deposition, it is plasma enhanced chemical vapor deposition, laser plasma chemical vapor deposition, advanced plasma clever chemical vapor deposition, and it is hydroxic plasma chemical vapor deposition method. Deposition of catalyst by sputtering, proper care of substrate under vacuum and pressure, flow of argon and methane under the high pressure at increased growth temperature, switch off the gas flow and decrease the temperature, and then we characterized our single walled chemical vapor deposition, SEAM and TEM. These are some optimization parameters that how we can deposit the temperature if we there is a weight uptake and the deposit temperature graph showing on a right side, and the other side it is deposit time minute and the weighing uptake. There is a very simple instrument used in chemical vapor deposition that when we goes, there is a heating coil in a isolated box, and there is a target and there is a substrate at which we try to grow our carbon nanotube. And while all the process being happening over there, some like these, this is the graph, this is just a small picture showing on a right side. It is of the perimeter of 200 nanometer size. So these cylindrical structures are actually carbon nanotube. There are some advantages and disadvantages of a thermal chemical vapor deposition method. The dimension of carbon nanotube can be acquired according to need. This is the biggest advantage. Easy to control, manipulate. Raw materials are abundant and availability readily. High quality and vertically aligned carbon nanotubes can be synthesized easily by this method. But the biggest disadvantage is that it needs a very high temperature, which is very not which is very rare. It cannot be obtained, it cannot be found in day-to-day laboratory environment. So this is of course so much costly. Laboratory substrate preparation, yes, laborious substrate preparation is very high to yield, very perfection and expertise is needed to compliance this type of method. Now the after all this thing, what are the hurdles in front of us while synthesizing the carbon in a tube? It's one is electronic heterogeneity, orientation, size and density, high purity mass production. You see, electronic heterogeneity is a very technical term. You see, when we try to grow the carbon in a tube, the carbon in a tube grows in amount of bulk. So when the carbon in a tube are of chiral nature, it is electrically conductor, and when it goes to the armchair it becomes insulator. So it is very hard to find out that which carbon nanotube is an armchair and it's chiral when there is a group of carbon nanotubes present over a 1 nanometer square area. So that's the biggest heterogeneity issue with carbon nanotube. Orientation is obviously that sometimes the dimension is all the radial diameter of all the carbon tubes are not same. That's the orientation problem. Similar for size and density, and high purity mass production is very big hurdle in the field of synthesizing carbon in a tube by using thermal chemical vapor deposition method. So obviously there are some conclusions that we can made by this video that TCVD is very promising and economic, well aligned and homogeneous carbon nanotubes can be grown. Carbon nanotubes